Hi everyone, I'm Huilin Xiong and I'm glad to be here with my teammate Chia Li.
Hi.
And we are going to present our parallel project, Parallel Lossless Compressors. So in this project, we parallelize two compressors. The first one is LJ77, which uses a sliding window, and another compressor is Huffman tree. This one uses the building the Huffman tree according to the character frequency. And we parallelize these two functions by partition the original file into different blocks. And so each thread is responsible for one partition, and the details can be seen in our implementation. And so now I'm going to show you the test. So in this file, we have some text file, and this function executes Huffman coding, and this is a sequential version. We can see the execution time is 170 milliseconds, and then we set the thread number as 16. We can see the speed up is about 10 times, and then we'll check if the result is correct using the decoding function. This is the decoded file, and we use diff. Yeah, there is nothing different, so it works. And then we will check the performance of LJ77. This time we use a different text file, which is AngularJS, a source code. Yeah, the War and Peace is a literature. Yeah, it takes about 9,000 milliseconds. And then we set the thread number equals to 16. We'll see that the speed up is about 15 times, which is a great speed up. And then we will check if they have the correct results. This is the decoding function. And we will check the decoded file and the original file have the same size, have the same contents. Yeah, and that shows this size. We can see that the compression ratio is also very good. The encoded file is already the half size of the original file. And so that shows the effectiveness. And now let's show us the analysis of the results.
Thank you, Huilin. Now let's talk about the comparison between Huffman and LJ77 on these three different test cases. The first two is the OMP's the normal, and the last one is the Angular.js, the source code. We can conclude that the LJ77 is generally more parallelizable comparing to the Huffman coding. And one interesting observation I want to talk about is the compression ratio. LJ77 shows a much better ratio on Angular.js comparing to Huffman's or comparing to itself on War and Peace. We guess it is because of the nature of the D2 algorithms that LJ77 performs much better when content is more duplicated. That is the Angular.js. And while Huffman coding performs much better when the byte patterns show greatly different frequencies. And there are also other reasons why the parallelism speedup got limited. One is the workload distribution not even. And one more thing I want to talk about is that why we have not applied GPU parallelism. Let's see this important data that more industrial compression algorithm has achieved more than 500 megabytes of throughput. And while our PC bus bandwidth is 900 megabytes, so there are definitely no reason to copy the data from CPU to GPU, conduct tasks, and copy back. So with the benchmarks, we can draw some conclusions here. For some famous implementation, such as Facebook STD, they usually combine these two algorithms, which is the Lampalzif family, such as LJ77, and the Introvic encoding, such as the Huffman one. And if they combine these two stages of time T1 and T2 of m megabytes of size, we can actually guess their potential speed up. That's all. Thank you.